Okay, in this video, we're going to look at applying Hess's Law. Hess's Law pretty much states that if we don't know the delta H, or the energy involved in a reaction, we can use delta H's, or energies from equations that we do know, and sort of substitute those delta H's in, and from those equations sort of create our unknown equation and be able to figure out our delta H for our unknown equation from delta H's from equations that we do know. So what that looks like, how we apply that. So in this problem, we need to find the delta H of our pink reaction, which we don't know. But we've been given all of our blue reactions to help us figure out our delta H of our pink reaction. But what I want you to notice first is I've kind of written this in a different way than you'll probably see it on your test or your quiz. You probably won't see it like this on your test or your quiz, but you might see equations written like this in other places on your test or your quiz. So our first blue equation, 1/2 H2 plus 1/2 F2, forms HF gas plus 273 kilojoules. What that tells us, since our energy, kilojoules means it's energy, because kilojoules is a unit of energy. So what that tells us is that this is an exothermic reaction, because our energy is one of our products. So it's releasing energy. So it means the delta H for this equation is actually equal to negative 273 kilojoules. For our next equation, S plus 3F2 to SF6, that means, plus 1,220 kilojoules means the same thing, that this equation is also exothermic and it's releasing 1,220 kilojoules of energy. So my delta H is equal to negative 1,220 kilojoules. And same thing with our last, because my energy is on my product side, my delta H is going to be negative 21 kilojoules because it is a exothermic reaction. If my energy, if I had this instead, 21 kilojoules plus H2 plus S to H2S, my delta H would be positive 21 kilojoules because my energy, it's kilojoules, there we go, because my energy is on my reactant side. So I'm actually adding energy to this reaction, to my two reactants to form H2S. Okay, so if your kilojoules, if your energy is on the product side, it's an exothermic reaction, it's releasing heat. If your energy, your kilojoules, are on your reactant side, it's absorbing energy and an endothermic reaction. Okay, so just something to keep in mind on your test. So how do we use Hess's Law? Well, we need to use these equations. We need to plug them in for our pink equation. So I'm going to start with my reactants. And what I'm going to do is I'm going to look at my two compounds in my reaction, my H2S and my 4F2, and I'm going to see if one of these, either my H2S or my F2, is only in one of these equations. So my H2S, I'm going to look and I see my H2S I find here, and my F, do I find it anywhere else? H2S? No, I don't see it. And my F2 I find here, and only, oh no, it's there too. Okay, so for this one I'm going to start with my H2S and see if, so I'm going to use this equation, equation number 3, H2 plus S to H2S. I'm going to use that to plug in for my H2S reactant. Okay, so what this is going to look like, but first I have to compare my H2S in my blue equation to my pink equation. So I have to compare what I have in my blue equation to what I want in my pink equation. So I have the same number of moles. I have 1 mole of H2S in each of the equations, but in my pink equation it's a reactant, and in my blue equation it's a product. So I need to flip this equation. So it's going to become H 2S plus, oops, sorry, actually we can ignore our energy for now because we've pulled it off to the side, so we can ignore it. It's H2S 2 H2 plus S. And since we flipped our reaction, whatever we do to the reaction, we have to do to our energy. So our delta H becomes, our delta H for this reaction becomes 21 kilojoules. Because when we flip it, it means we flip the sign. So if it's negative, it becomes positive. If it's positive, it becomes negative. So now I'm going to look at my F2. And I'm actually going to skip my F2 because I have two equations with F2 in it. So I'm going to look to my reactants and see if I can eliminate one of those equations. And I have three equations, but I have three parts to my pink equation. So 1, 2, I have two reactants and two products, but three equations. So potentially one of the parts, either one of my reactants or one of my products, isn't going to have a corresponding blue equation. So I'm going to skip F2 for now and go over to my reactants, or I'm sorry, excuse me, to my products, and see if I can substitute in for those. So I'm going to look for my HF and see if I can find my HF that is only in one equation that I haven't used, so either the first or the second, and is in only one of those equations. So here it is, HF, and it's only in my first equation, it's not in my second equation. So I'm going to use that equation, my first equation, to substitute in for my pink product HF. So the difference between the two is they're both products, both in my white equation and my pink equation, what I have and what I want, they're both products. But in what I want, in my pink equation, I have 2 moles of HF. In the equation that I have, I only have 1 mole. So I need to multiply this whole thing by 2 to make my pink and my white match. So this, but I don't have to flip it because they're both products. So 1/2 times 2 is 1. So this becomes H2 plus 1/2. And because remember, whatever I do to one part of the equation, I have to do the entire equation and to my delta H. So 1/2 times 2 is 1. So that's H2 plus F2. And HF times 2 is, I just have 1 mole, so it becomes 2 HF. And my delta H, I'm going to multiply by 2, but it's going to remain negative. But my delta H is going to become negative 273 times 2. So it's going to become negative 546 kilojoules. Okay, so I have this and I have this taken care of. So now I have one more equation, and let's see which one that's going to match up with. And I'm going to match that up to my SF6 because my SF6 only occurs in this one equation. I'm going to skip using my F2 because my F2 I actually have in 2 equations, in my first equation and my second equation. So I'm going to skip because remember I said I had 2 reactants and 2 products, so likely one of my parts of my pink equation or my pink reaction I wasn't going to use. So the F2 is what I'm not going to use. I'm going to use my SF6 instead since that only occurs in one of my white reactions. So SF6, between my white and my blue, there is no difference. They're both 1 mole and they're both products. So this gets to stay the same. So S plus 3F2 to SF6. And my delta H gets to stay the same. Oops. Don't know where I was going with that. My delta H gets to stay the same. And it stays at negative 1220 kilojoules. Now what I need to do, and I'm going to change colors again. Now what I need to do is I need to add everything up. Because now I need to put all my green pieces together to create my red equation. Actually, we'll go back to red. So I'm going to look at all of my reactants versus all of my products, and I'm going to see if I can eliminate things on either side of the arrow. So my H2S, I actually want that to stay. I look over here and they have to go together, so I can't use pieces like my H2 and my S. I can't cancel both of those out to cancel my H2S. That's not how that works. They need to be together in the same compound. So H2S doesn't exist in the products of any of my reactions. I have no H2S. So that's going to stay. So now I move on to my H2 and my F2. So my H2 and my H2 doesn't cancel anywhere. Oh, nope, sorry, it does. I've got H2 right here, and so I've got an H2 reactant and an H2 product, so those cancel out. And my F2 isn't anywhere on my product side, so that doesn't cancel. Move down to my S. I have an S on my reactant side and on my product side, so that cancels out. 3F2. I don't have any F2s on my reactant side, so it doesn't cancel out. So what I'm left with, now I just rewrite my equations, but I combine all three equations, but I combine it just with what isn't crossed out. So I'm left with H2S plus F2 plus 3F2, but I can actually combine those together. So this can actually become 4F2 to 2HF plus SF6. And I checked to make sure that that's what I wanted up above in my equation, and it is, thank goodness. So now that I've added my equation and I've made my two pink equations match, so now I know that I've done my delta H's correctly. So now I need to add my delta H's. So 21 plus negative 546 plus negative 1,220. So I get 21 plus negative 546 plus negative 1220. And that's going to give me a delta H for my reaction. Let's see, negative 546 plus negative 1220. That's going to give me a delta H for my reaction of negative 1745 kilojoules. So I know that this reaction, I know that it is exothermic because my delta H is a negative. Okay, so that is how I can find the delta H of my reaction using Hess's law.